Alright, so this is how to create two-axis programs on the CNC mill. So this is the Bridgeport mill, and usually it doesn't come with like a two-axis capability, but this has a ProtoTRAK KMX retrofit CNC attached to it, which means that both handles can move, but the Z like doesn't move. So this has a lot of capability. Actually, so first thing you want to do is when you want to do a program, you have to know, like, is this right for a two-axis mill? And the way you know that is if it's just a regular 2D profile. You can do any 2D profile that you want, and if it's a 2D profile, you're probably good for it to be done on this machine. So the first thing you want to do is go to your setup, and over here in setup, you have a tool table and you have a tool path. So if you go to tool table, okay, so first I have to go to program. Hold on. Okay. Setup tool table. You'll have a diameter, Z offset, Z modifier, and tool type. You don't have to mess with Z offset or Z modifier because it's two axis. So you go to data left, data left, data left. This is your diameter of the tool, and it's important that it knows it, because when you are doing the program and you have the wrong diameter, then you're gonna get the wrong coordinates, and it's not gonna know where to go. So let's just say you have this end mill here. This end mill, we can just quickly check, is a ½ inch. So we're gonna do a 0.5, and this is you can either choose a rough end mill or a finish end mill for end mills. But again, there's other stuff here you can choose. You can either choose if it's a drill, a center drill, whatever. But usually if you're just going in one operation, you just go finish end mill. Then once your tool is set up, you can go to your program. So this is where you define your program. And over here we have a program name, we have a scale, we have an input Z. You don't have to worry about these two. Program name, you can just call whatever you want to save it in the thing. It's important that you have like good program names, otherwise you like lose your files. Like I usually have the bad habit of just doing pressing down a bunch of random numbers and like hoping I remember this later on. But like this is probably not the best strategy, but it is what it is. Alright, so over here you have go to begin, go to end, and then go to number. So the way you begin your program is just click go to begin, and then you get a bunch of options. So right here I have a position drill that I had to put down in order to see the tool table. But let me just delete this. And we have a bunch of options here. So you have a position drill, you have a mill, you have an arc, pocket, profile, or a sub. So I guess I can just like go through all of these. The position drill. This is good for nailing down like coordinates of like where you want the machine to go, but without it actually milling or drilling anything. So this will just like aim your head on that coordinate spot. So you can either do like a bullet hole or a position. So let's just say like you have a feature that is 1 inch to the right and then 1 inch up. Then your position drill will move your head 1 inch to the X and 1 inch on the Y. So it's very good for orienting and positioning like holes or very like repeatable processes. This is the mill, and this is probably what you're going to be using a lot of the times. So when you click on mill, on your drawing or whatever, you're going to have like a contour that you want to follow, a 2D contour. So what you do is you look at the drawing, you see where it begins. Let's just say it begins at 0, 0, and then your mill program is going like straight up. So you want your end mill to go from here straight up. So then you have the option of saying 0 increment on the x, or pressing 0 absolute. So in this case, it does the same thing. And real quick, the difference between incremental and absolute. Incremental is from where the last program ended. Absolute is from where 0, 0 is on your all based off of the 0, 0 on your machine. Incremental is where your last program ended, or where your last position was when your last event ended. So in this case, we began at 0 and we want to go straight up. You can either press 0 increment or 0 absolute, doesn't matter. And your Y, you want to go, again, it doesn't really matter. You can use +1 increment or +1 absolute because you're starting at 0, 0 anyway. Corner rate, so Conrad is corner radius. Because you're going straight up, you're not going to have a corner radius, so you just do 0. Tool offset is basically where your tool is in relation to the contour. So if your contour is following this caliper line, you want your tool to cut left, then you choose tool left. But if you want your tool to cut right, then you choose cut right. Or if you want your tool to cut on the center, then you choose center. But usually you're gonna be cutting on the left side. So number 2. Feed rate and tool number. Feed rate you usually just like memorize. I usually just do like 5, 7.5. It's fine. And then tool number, we're just gonna do number 1 for the 0.5 end mil. And now you get to choose like you get the opportunity to either continue or not continue. So if you have a contour that you want to continue, you want to select yes. And then you can either continue to position drill, continue to mill, continue to arc, or do all these other things. I'm going to continue to mill. And what it'll do is it'll completely get rid of all the unnecessary stuff that you already defined in here, and it'll automatically go to your X end, Y end, and corner radius. So now let's just say you want your end mill to go right. Now that you've gone up, you want to go right. So so now you do your X end as +1. You can do increment or absolute. And your Y is not going to be changing. So this is a good opportunity to demonstrate incremental and absolute, because in increment, you can either choose 0, because your last Y ended off at 1, or you can choose 1 absolute. 0 increment and 1 absolute means the same thing. So we can do 0 increment. We're staying at the same Y that this last event ended at. And corner radius, let's just do 0. And continue, let's just say no, we're not going to continue. So now that we have a basic program defined, let's look at it and see there's a look button. And that's what it looks like. So just going up and going to the right. And you can see there's a 0 corner radius there, but in reality, there always will be a corner radius. It's just defined by your tool itself. So in this case, you have a 0.5 NMO. It's fairly large, so you're going to have you will have a corner radius there, whether you defined it or not. But let's just say you want to have a corner radius. You go page back, and you go to the first event, and maybe you want a 0.25. See if this works. So there we go. We got a little arc there, arc fillet, and that's how you can do those sort of fillets. And yeah, so this is basically the mill command, and you can keep going. Just define your program or your contour, and there's also the arc. And the arc is a little more complicated, but essentially, it's essentially the same thing. You choose your X end, your Y end, where your arc ends, and you also choose the center of your arc, so your X and Y center. Sometimes you might have to do a little bit of math to figure that out, but one thing about center is if you know your X end, your Y end, and your X center and your Y center, you always set your corner radius to 0. Yeah, that's pretty much it for that. So we've done position, drill, mill, and arc. Now pocket. So pocket, you have a few options. You have circle pocket, rectangular pocket, irregular pocket, or face mill. I'll just be focusing on these two. So circular pocket is very useful. It's basically when you have a hole feature and you want your end mill to machine out that hole. And what it'll do is it'll go in a spiral pattern and it'll machine out that pocket. So let's just say you found your feature, you want it to be on 0, 0. And the radius is basically just the radius of the hole that you want. Let's just say we want a 0.1 hole, or 0.1 radius, or a 0.2 diameter hole. And the direction I usually choose as counterclockwise. And there are a few distinctions between clockwise and counterclockwise, which corresponds to like what is climb milling and what's conventional milling. If you want, you can do some research on that yourself. Like finish cut, we'll do 10 thou. That's pretty normal. Feed rate 7.5. And then finish feed rate, you can go a little higher. It's 10. So what finish does is it'll just do like a small pass at the end, and it'll remove like an extra 10 thou, or not an extra 10 thou, but like it'll remove 10 thou of material. It'll leave 10 thou of material to remove as a finished pass. And then we'll choose tool number 1, which is what we defined in our tool setup. And now when you take a look, you see a circle there. And let's just say, so this program runs once, and that's it. But if you have a hole that extends deeper, let's just say your hole is 500 thou in depth. You cannot take off 500 thou in one pass. In that case, you go to sub here, and then sub repeat this program. So number one, first event 1, last event 1. There's no offset, so you do 0 increment. And you want to repeat it the amount of times that you can take off. So you need to say you can take off 100 thou each pass, and you want your depth to be 500 thou. You repeat it 5 times. So that's how you do that. And now when you go back to setup and tool path, the tool is too large for the program geometry. Yeah, that's correct. So let's go back to our program. I made a mistake. This end mill is 0.5. This is a good opportunity to see what went wrong. I defined a radius of 0.1 or a diameter of 0.2, and that's not possible with this end mill because the end mill is larger than the diameter of the hole. So in this case, we'll just go with something big. We'll just do like we'll just do 0.6. Now when you go back to setup and toolpath, you can see what that's like. So actually, let me increase the radius a bit so you can see what the spiral looks like a little bit more. There we go. So what it's going to do is go out in a spiral and take off material that way, and then your program will end, and then it'll say check Z. It's important that you whatever you use, your table or your spindle, you increase your spindle, click go, and then your program will say set Z. Then you go down to your depth, another 100 thou, run the program. After the program's done, it'll say check Z, increase your spindle, press go, and it'll say set Z, and then repeat the same process. It's important that while the end mill is in your part and it says check Z on your program, do not press go, because if you have a event that immediately right after where it goes into the part, it will not extend back out for you to have time to react. So it'll just like go straight into your part, and then the program, like your machine, will crash. So don't do that. Go back to program. That's your circle pocket. There's nothing much to it there. I think circle pocketing can be used when you have a circle that, or when you have a hole that's larger than like a drill size. So the largest drills in this drill kit go up to 0.5, and you have a hole that's bigger than that, then you would use a circle pocket. Another use for this is if you have a counterbore, and you need a counterbore like a quarter 20 screw. What you do is you get like a smaller end mill, and then you would go down the counterbore depth, and then you would also do the radius of the counterbore. Another use of this is for bearing fits. So just say you have a very precise bearing. What you do is you would set the radius a little bit under the OD of the bearing, and then like around 3 thou. And then what you do is you test fit the bearing, see if it goes in or not. It shouldn't go in. Then increase by like 1 thou or half a thou each time. And then what you can do from there is you can just like, once you see it starts to go in, you can take it out and just like hammer it in. And then you got a pretty basic bearing fit. So yeah, I mean, this is like a very accurate way of doing holes, and yeah, circle pocket is very useful for that. And now let's just do rectangular pocket. So rectangular pocket is pocketing, so you're still doing pockets, but instead of a radius, you have two coordinates. Your first coordinate is the left side of your rectangle, your lower left side, and your second coordinate, your x3, y3, is your upper right side of the rectangle. So let's just say you have a rectangle's pocket that starts at 0, 0, and goes to 5, 5. You have a 0 corner radius. You wanna go counterclockwise, finish cut 10 thou, 7.5 feed rate, finish feed rate 10, 201. Take a look. And it just does a rectangle or a square, but yeah, the tool will, go like that. I can show you the tool path, but let's see, set up. Yeah, so the end mill will just go like that. It'll pocket out material. This is useful for when you have oversized parts, and instead of fly cutting like 200 thou of material, like 300 thou material, you use a large end mill and you rectangular pocket it instead of fly cutting off that material. So that's good. And then let's see back here. So under pocket we have profile and profile. So if you have a irregular profile, what this will do is okay. Before I do irregular, let's just do circle. So a circle profile will only cut the outside of the circle. Pocket is cutting the inside. Profiling will only cut the outside. So it is it's basically just like what a water jet does, which is what it cuts a profile, but it's with an end mill. I mean, yeah, everything else is the same. Delete. Same thing with rectangular profile, it'll only cut the outside edge. So if you want, like let's just say like the water jet is being taken up right now, and you need a part to be water jetted, and you have the 2D contour, you'd use a you'd profile the part, and you do a profile instead of doing that. You can also do an irregular profile, which is basically just a combination of whatever. It's like it's basically just like your milling feature, but you can, yeah, it is like the milling feature, but it only cuts the outside. So you can do whatever profile that you want. You just have to define your X and Y, and yeah, you can do arcs, you can do mills, whatever. And that's pretty much it. Again, I showed you what sub does. There are these other ones here, like sub rotate. Sub rotate will, rotate like a command about a degree. Sub repeat will be your most commonly used command. If you have a hole that needs to go down to depth, you're not going to take off like 100 thou or 500 thou right away. So I'm going to sub repeat that. But that's pretty much it. If you want to save your program, what you do is you go to mode, you go to program in and out, cannot find USB drive. So in this case, this doesn't have a USB drive in it, but if it does, or if it did, then what you do is you click save, you save the program, and then that's pretty much it. So go back to your program, and then you want to start a new program. You type in whatever name you want, and then you just delete all the past events that you had. If you want to go back to your program that you saved, you go to program in and out, and you would choose the program on the USB drive that you saved it to, and then you'd click open, and then go to mode, go to program, and it'll be there. So yeah, this is pretty much it, and there's not much more to it. It's actually very simple. So once you do a few programs, like, you'll know what to do. It's very useful, and oftentimes it's better than, you know, putting it on the lathe, or better than water jetting it. So it's very good to know how to do a 2-axis part on the mill, and yeah, we found it useful.